On June 26, 2026, Ukraine reportedly struck a railway bridge in Sabivka, an area of the Luhansk region under Russian control. The bridge sits on a railway line connecting Russian-controlled areas in Luhansk and Donetsk, where military trains may transport fuel, ammunition, military vehicles, spare parts, and reinforcements to the Donbass front. In modern warfare, a bridge does not have to collapse completely to make a difference. If the railway is disrupted, trains may have to slow down, change their schedules, or use alternative routes. Each of those changes makes the supply system slower, more complicated, and more demanding to protect. Ukraine is believed to have used the UJ-26 Beaver long-range attack drone in this strike. If that report is accurate, Sabivka may show that Kyiv is expanding the battlefield deeper into Russia's military logistics network, where railway bridges, transport hubs, and supply convoys are all becoming potential targets. So why can one railway bridge at Sabivka place pressure on the Donbass front? And why does this railway line play such an important role in Russia's ability to sustain its campaign in eastern Ukraine? Let's find out with military force. The Sabivka railway bridge mattered because it sat on a route Russia needed to keep the Donbass front supplied. In eastern Ukraine, rail lines are not only transport links. They are the backbone of large military movement, especially when an army must feed artillery positions, rotate troops, move fuel, and return damaged vehicles to service. This route connected Russian-controlled areas in Luhansk and Donetsk, giving it direct value for Moscow's operations in the east. A train can carry far more cargo than a convoy of trucks. It can move ammunition in bulk, deliver fuel in large quantities, and transport spare parts or heavy equipment with fewer vehicles and less road traffic. In a long war of attrition, that difference matters because the side that moves supplies faster can keep pressure on the front for longer. The Donbass battlefield depends heavily on rhythm. Artillery units need shells before they can fire. Infantry units need replacements before they can continue assaults. Armored vehicles need fuel, repair crews, and parts before they can return to combat. If those flows remain steady, Russian commanders can maintain pressure across several sectors at the same time. If they slow, the effect can appear first as delay, then as weaker attacks, and finally as less freedom for commanders. A damaged railway bridge can create a problem larger than the blast site. The bridge does not have to disappear from the map. A damaged section of track, a weakened support area, or an unsafe crossing can force railway crews to inspect, repair, reduce speed, suspend traffic, or reroute cargo. Each step consumes time, engineers, security units, and equipment. During that period, cargo that should have moved directly toward Donbass may wait in depots, shift to another route, or be broken into smaller loads. For Russia, this is important because road transport is less efficient and more exposed. Trucks can handle final delivery, but they are not a perfect replacement for rail when the cargo includes shells, fuel, engines, armored parts, and heavy military stores. Sabivka shows how logistics has become part of the battlefield itself. The bridge was valuable because it helped connect the rear system to the fighting line. Once that connection is damaged, the impact can move along the entire supply chain, from storage sites in the rear to units waiting near the front, at a more vulnerable moment under pressure during sustained offensive operations across multiple sectors simultaneously. From this role, the strike should not be viewed as an isolated blow. It fits a wider Ukrainian effort to find weak points inside Russia's supply network and wear them down before supplies reach the front. The strike on the Sabivka railway bridge fits a broader Ukrainian effort to weaken the system that keeps Russian forces moving in eastern Ukraine. Instead of focusing only on trenches, armored vehicles, and artillery positions near the front, Ukraine has been looking for the routes and facilities that allow those forces to keep fighting. A bridge, a station, a depot, or a junction can be as important as a weapon system when it controls the flow of fuel, ammunition, and reinforcements when operations depend on speed, volume, and movement. This logic matters because Russia's strength in Donbass depends on steady delivery. If ammunition arrives on time, artillery can keep firing. If fuel reaches staging areas, vehicles can move when commanders need them. If replacement troops and spare parts continue to arrive, pressure can be maintained across several sectors. By striking transport links, Ukraine is trying to disturb that rhythm before the supplies reach Russian units at the front. Ukraine does not need to destroy the entire railway network to create a serious problem. It only needs to damage the right points at the right time. Bridges, rail crossings, stations, loading zones, and switching areas can all become bottlenecks because traffic must pass through them in an organized sequence. When one of these locations is damaged, the pressure spreads beyond the visible blast damage and begins affecting the timetable of the wider supply chain. A train may have to stop for inspection. Cargo may wait at a depot until another route becomes available. Railway crews may reduce speed across a damaged section. Military planners may be forced to move the same cargo through a longer path. None of these problems must be permanent to matter. In a fast-moving campaign, even a temporary delay can affect when artillery shells arrive, when fuel is distributed, or when troops are ready for the next operation. Every damaged node creates new work for Russia. Engineers must inspect the bridge, repair crews must bring equipment forward, and security units must protect the site while repairs are underway. At the same time, commanders may need to shift cargo to alternate lines or increase road transport. These choices use vehicles, fuel, personnel, and planning capacity that could otherwise support combat operations. The larger effect is uncertainty. A logistics system works best when commanders can predict the movement of supplies with confidence. If key transport points can be struck without warning, every schedule becomes less stable. Russian officers may need backup routes, reserve vehicles, extra guards, and more air defense coverage around transport infrastructure. Even if supplies continue moving, the system becomes slower and heavier because each movement requires more protection and more coordination. This is how Ukraine shifts part of the war from the front line to the transport network behind it. Russian soldiers may still be fighting in trenches, but the supplies that support them must pass through vulnerable routes before reaching those positions, through routes that cannot be hidden from surveillance. By attacking logistics, Ukraine tries to weaken Russian combat power before it appears on the battlefield. The Sabivka strike should therefore be understood as part of a wider method, not as one isolated attack. Ukraine is looking for weak points where a limited strike can create a larger operational effect. The result may not be immediate collapse in many cases. It may be slower movement, higher protection costs, longer repair cycles, and less freedom for Russia to move resources quickly across contested regions under constant operational pressure every single day. But reaching targets this deep is not simple. To strike strategic infrastructure behind Russian positions, Ukraine needs a system that can cross distance, avoid unnecessary exposure, and reach places that ordinary battlefield weapons cannot safely reach without risking pilots or ground forces. Ukraine is reported to have used the UJ-26 Beaver long-range attack drone in the strike on the Sabivka railway bridge, but this point should be handled with caution. In wartime, technical details often appear before they are confirmed, especially when the target is inside Russian-controlled territory and the attacker has reasons to protect launch sites, flight routes, and methods. A careful script should therefore say that the Beaver was reportedly used, or that available information suggests its role. That caution does not weaken the analysis. It makes the story more credible. The central point is that Ukraine is using long-range unmanned systems to reach logistics targets beyond the reach of many battlefield weapons. A bridge that once seemed distant from the fighting line can now become part of the battle space. The value of a system like the UJ-26 Beaver is that it can strike without placing a pilot or special operations team directly inside the danger zone. Aircraft face radar, missiles, and the risk of losing trained pilots. Ground teams face checkpoints, patrols, and the difficulty of moving through occupied territory. A drone reduces those risks while still allowing Ukraine to apply pressure deep behind Russian positions. For a target like a railway bridge, this matters. The attacker does not always need a massive warhead or collapse. A bridge can become difficult to use if the strike damages the track, the bridge deck, the support area, or the connection point where rail traffic enters and leaves the crossing. Limited damage can force inspections, repairs, and traffic restrictions before military trains can safely pass. Long-range drones become more dangerous when they combine distance with a careful approach. Reports often describe systems like the Beaver using low-altitude flight to reduce exposure to radar. Flying low does not make a drone invisible, but it can shorten the detection window by using terrain, trees, buildings, and ground clutter to complicate tracking. That shorter window can matter when the target is protected by layered defenses. The final phase is also important. A drone approaching a railway bridge must identify a specific target area. It may need to follow the shape of the rail line, recognize the bridge structure, and aim at a section where damage creates the most disruption. This is why route planning, reconnaissance, and final guidance are as important as the explosive charge itself. The strike is not only about reaching the area, it is about reaching the right point. The UJ-26 Beaver represents a wider trend in Ukraine's war effort. Kyiv is trying to make Russian logistics feel unsafe at longer distances, not only near the front. A drone that can reach a bridge, depot, fuel site, or railway facility forces Russia to think about protection across a larger map. That creates pressure before another strike happens, because every route may require more guards, more sensors, and air defense coverage. This is where the strategic value of long-range drones appears. They are not only weapons for explosions, they are tools for stretching the opponent's attention. Each successful strike suggests that other routes may also be vulnerable. Each attempted strike forces Russia to spend more effort protecting rear infrastructure. However, this value depends on the reaction it creates. A long-range drone matters most when it forces Russia's defensive system to face a wider problem than guarding one bridge alone, especially when similar routes, depots, fuel points, and rail nodes can be placed under pressure across the occupied rear. Russia has built layers of air defense and electronic warfare around important military areas. Systems such as Nebo-M, S-350, Tor, Panzer S-1, and Pol-21 are often described as parts of that shield. Each has a different job. Long-range radar can search early. Medium-range missiles can engage aircraft, drones, or cruise missiles. Short-range systems guard a bridge, depot, or command site. Electronic warfare can disrupt navigation and control signals. But the Sabivka strike must be handled with caution. There is no confirmed evidence that every one of these systems directly took part in stopping this attack. The analysis should not claim that all of them failed at Sabivka. Russia may have capable systems, but capability on paper does not equal complete protection across every supply route. The main challenge for Russia is scale. The occupied rear area contains many military targets that need protection. Railway bridges have to be watched. Fuel sites need guards. Ammunition depots need cover. Train stations, repair yards, road junctions, and staging areas also require attention. If Ukraine keeps hitting logistics, Russia must decide which sites receive the strongest defense and which remain exposed. That creates a hard trade-off. A Tor or Panzer system near one bridge cannot protect another rail route many miles away. Radar coverage may detect a threat, but interception still depends on terrain, range, reaction time, target identification, and crew readiness. Electronic warfare can interfere with some drone signals, but it cannot place an invisible wall over every structure. The more points Russia defends, the thinner the shield becomes. Small drones make this problem sharper. They are not large aircraft flying on predictable paths. A low-flying UAV can use terrain, buildings, trees, rail lines, and clutter to reduce detection time. It may appear late, approach from an unexpected direction, or force defenders to decide before the full picture is clear. Even a strong defense can be pushed into a race against seconds. This does not mean Russian air defenses are useless. They can still shoot down drones, protect high-value sites, and force Ukraine to spend more weapons. But modern drone attacks are often designed to reduce the defender's comfort zone. A small target flying low toward a fixed bridge can turn a technical contest into a timing problem. If many routes must be watched at once, that problem becomes harder. For Ukraine, the aim is not only to slip one drone through one defensive ring. The aim is to make Russia spread attention across a larger map. Every threatened bridge may need radar focus. Every rail junction may need guards. Every depot may require repair teams, camouflage, and air defense cover. These demands may not destroy Russia's logistics immediately, but they can make the system heavier, slower, and less confident. That is why Sabivka matters beyond the damage. It points to a wider pressure campaign against Russia's rear area. Ukraine is not only testing one defensive battery, it is trying to make Moscow protect many points. This dispersed pressure shows that the goal is not only to penetrate a single defensive layer, it is to make the entire Russian war support system harder to operate. The Sabivka bridge strike reflects a wider shift in Ukraine's campaign against Russia's war machine. The target was not only one railway structure, and the purpose was not only to create a visible explosion. The deeper aim was to disturb the system that moves Russian supplies from rear storage areas toward units fighting in the east. In that sense, Sabivka fits a pattern in which Ukraine looks for points that connect transport, storage, repair, and operations. This matters because Russia's military power is not created only at the trench line. It is also built in depots, rail yards, fuel sites, repair areas, and transfer points. A shell fired near Donbass may begin its journey far away from the gun crew that uses it. Fuel for an armored vehicle may pass through several storage stages before it reaches a battlefield road. When Ukraine strikes these links, it attacks the process that allows combat power to appear at the front. The targets now being prioritized show that logic. Bridges help trains cross difficult terrain and keep cargo moving. Rail lines carry heavy loads over long distances. Ammunition depots store shells for daily fire missions. Fuel sites keep vehicles and transport columns running. Transfer hubs organize cargo before it is pushed closer to fighting units. Each location has a different role, but all support the same Russian need to keep the war supplied. The important effect is accumulation. One damaged bridge may be repaired. One depot fire may be contained. One rail delay may be solved. But repeated strikes force Russia to keep reacting. Crews must inspect damage, move equipment, rebuild sections, improve camouflage, strengthen guards, and send more protection to pressured places. Every response uses time, people, vehicles, and planning attention. This creates operational friction. A shipment may still arrive, but it may arrive later. A route may still function, but it may require more escorts. A depot may still operate, but it may need more dispersal and protection. The system does not have to collapse for Ukraine to gain value. It only has to become slower, more expensive, and less predictable than Russian commanders want. There is also a political layer. Moscow has tried to present occupied rear areas as controlled and secure. Strikes on bridges, depots, and transport routes weaken it. They show Russian troops, local authorities, and public that distance from the front does not guarantee safety. For Ukraine, this is not only battlefield pressure. It is also pressure on the story Russia tells about control. If these disruptions continue, the pressure will not remain limited to railway maps. It will move on to roads, convoy schedules, guard units, repair crews, and formations waiting for supplies near the front. It will also shape how commanders plan, because every supply decision must account for delay, exposure, protection, road capacity, unit demand, escort availability, repair limits, available manpower, weather conditions, engineering resources, operational priorities, and transport capacity. If key railway routes remain disrupted, Russia may have to move more supplies by road. That would not be a simple replacement. Rail transport is built for volume. A train can carry large amounts of fuel, ammunition, spare parts, and heavy equipment in one organized movement. Trucks can reach smaller destinations, but they require far more vehicles to move the same load. This matters in Donbass because Russian operations consume supplies at a constant rate. Artillery needs shells every day. Vehicles need fuel before they can move. Repair units need engines, tires, tracks, and tools to return damaged equipment to service. If railway traffic slows, these items may still move, but they may arrive in smaller batches and on less predictable schedules. Road transport also creates more pressure inside the logistics system. More trucks mean more drivers, more fuel use, more maintenance, more traffic control, and more recovery vehicles when something breaks down. Convoys also need escorts, route security, communications, and protection near loading points. Each added requirement pulls manpower and equipment away from other tasks. The risk is higher on the road. A train follows a fixed rail line, but it can move heavy cargo in a concentrated and planned way. A road convoy spreads that movement across highways, rural roads, junctions, bridges, and parking areas. These locations are easier for reconnaissance drones to watch. Once a convoy is spotted, FPV drones, artillery, mines, and ambush teams can turn movement into exposure. This creates a difficult cycle for Russia. To avoid rail disruption, it may use more trucks. To protect those trucks, it may need more guards and air defense coverage. To reduce risk, it may move at night, split convoys, or use longer routes. Each choice can reduce speed and increase cost. The effect may eventually reach the front line in quiet but important ways. A gun battery may receive fewer shells. A vehicle unit may wait longer for fuel. A damaged armored vehicle may stay out of service for another day. An assault may need more preparation before it can begin. That is why the value of the Sabivka strike is not measured only by the explosion. Its deeper value lies in how long-range drones are widening the battlefield, forcing Russia to protect the space between rear depots and frontline units, under pressure across routes once considered safer before. The Sabivka strike shows how long-range drones are changing Ukraine's campaign behind the front. The reported use of the UJ-26 Beaver matters because it points to a wider method, reaching transport targets that Russia once expected to keep working under protection. A damaged bridge will not decide Donbass by itself. Russia can repair tracks, redirect cargo, increase road movement, and place more guards around key routes. But every response requires time, manpower, fuel, engineering teams, and air defense attention. In a war of attrition, those costs matter because they slow the machine that keeps pressure on the battlefield. For Ukraine, the aim is not only to hit what can be seen from the front line, it is to make Russia's rear network less predictable and more expensive to run. If supplies move slower, combat power arrives weaker. That can become an operational gain before the next battle even begins. If you found this analysis valuable, please subscribe to Military Force and turn on notifications so you never miss our latest reports on global conflicts, military technology, and geopolitical developments. We believe every battlefield tells a larger story. Behind every bridge, every drone, and every military operation are decisions that shape nations and affect millions of lives. Understanding how wars are fought also helps us understand why lasting peace is so difficult to achieve and why preventing future conflicts matters just as much as analyzing today's battles.